Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 7th March 2023. The problem statement for today is max level sum in binary tree. This problem is based on binary search and binary search tree concepts, and this has been asked in Amazon interview. Let's now open this problem. Let's go through this given problem statement first. Here it is said, given a binary tree having positive and negative nodes, find the maximum sum of a level in a given binary tree. So as an example, it's given that this is the given binary tree. So here at first level the element is 4, and at the second level we have these two elements, and in the third level the following elements. So here we can see the sum of all nodes at first level, that means the 0th level is 4. Sum of all nodes is here minus 3, that means summation of minus 5 and 2, that will give minus 3, and sum of all node in second level is 6. So that's why here we have got the maximum sum is 6, so the output will be 6. In the second example given, here it is said that output is 17. So here we can see at this level, that means the level is 2. So at this level we have got the maximum sum, where 8 plus 5 is 13, 13 plus 4 is 17. So for solving this question, this binary tree will be given as an input, so the root will be provided to us. So for solving this, we just have to do the level order traversal for this binary tree, and for each level we have to calculate the sum of all the nodes that has been given there, and just we have to compare at each level that is it the maximum one or not, and wherever we get some value greater than the previous one, so we make that particular summed value as the maximum value. I hope this point is very clear. So just to save time here, I have prepared the solution. I'll explain it line by line. So let me just copy it. So here in this, if you can see that in this method, this root node has been given as an input. So here first we will check if this root itself is null, that means no element is there, then simply we will return 0 from here, and that will exit from this method. But if it is not null, then we are initializing a queue here. We are initializing a queue to store all the nodes in this queue. Okay, and here what we do, we enqueue the root node into the queue. We also initialize the variable max level sum to a minimum value of an integer, this one. Then we start a while loop and continue as long as the queue is not empty. In each iteration of this loop, we initialize a variable called level sum that is stored initially 0, and a variable level size to the size of the queue. We then iterate through each node in the current level and dequeuing each node and adding to the level sum, this one. Whatever the value we have got there after dequeuing that element from the queue, so the data stored in that node, that we are adding to level sum. If the dequeued node has left or right children, we enqueue them to the queue. So here this part is done. After processing all the nodes, then we check if level sum value is greater than max level sum. So if so, then we update max level sum and we repeat the loop for the next level. Once the while loop has completed, we return max level sum, which contains the maximum sum of any horizontal level in the given binary tree. So this is that simple solution here. So only one thing to keep in mind here, that instead of using this one level size, don't try to use q.size here. It might be very intuitive to just replace this variable directly with this here, but this should not be done, because here we are calculating the level size with the size of the queue at each level. But here in this for loop, we keep modifying that queue by adding left and right children as well. So if we add that q.size here, so that size of the queue that will vary at each iteration. So that should not be used here. we have to use that one with respect to this while loop, not with this for loop. So here at each level we'll get what is the size here and here, and once we are done with that, once we get that, then we try to iterate that all the nodes that has been added at a particular level, and we try to find if it contains left and right children, and we do the summation operation here. So I hope this point is very clear. So now let's try compiling this code. So here we can see we have got our output correctly. Let's try submitting the solution. Even the solution seems to be correct. Here it has covered all the test cases, and this problem has been solved successfully. So here, so talking about the time complexity of the max level sum function, that will be here. That will be big O of n, where n is the number of nodes in the binary tree. This is because we visit each node in the binary tree exactly once, and for each node we perform constant time operations such as enqueuing and dequeuing the node from the queue. The space complexity of the function is big O of m, where m is the maximum number of nodes at any level in the binary tree. This is because we use a queue to store the nodes of the binary tree, and the maximum size of the queue at any point in time is the maximum number of nodes at any level. So we are not storing all the elements of the given binary tree. We are storing all the elements at a particular level itself in the queue. In worst case, where the binary tree is complete binary tree, the maximum number of nodes at any level is n plus 1 by 2, where n is the total number of nodes in the binary tree. Therefore, the space complexity in this case is big O of n. So that is the worst case. So I hope this much is very clear. So yeah, so that's all in this video. I'll be providing the link of this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more such upcoming videos. Thank you for watching.